we are supporting fully the community to build on top of Falcon. It's not just by speeches and discourses, but it's more, we are concrete, we are providing more sort of support with compute. That is actually the blocking point for most of the members of the community to work on these large language models. So we are there to support, we are there to give a push. We believe that AI has to be open, has to be transparent, and has to be controlled by the community, and the community has to have a look into these structures and these models that we are building nowadays.
Welcome to another edition of Cloud Unfiltered. I am your host, Michael Chenitz, and today I have Hakim from TII. And tell us a little bit about yourself.
Yeah. So this is Hakim. So I'm from the Technology Innovation Institute. It's a research institute based in Abu Dhabi in the United Arab Emirates. And I'm here to discuss open source and open source AI.
That sounds great. And tell us a little bit about what TII does. I'd love to hear about that.
Sure. TII is, as I said, the research institute. It's actually the research arm of the ATRC, that is the Abu Dhabi Advanced Technology Research Council. So under ATRC, we have three sister entities. We have Aspire, that is more handling the program management and the business development. We have then TII, that is the research arm. We are doing the research. And then we have Venture One, that is the commercialization arm of ATRC. So in TII, we are hosting 10 research centers on different aspects of technology, including, for example, robotics, including biotech, space, and AI, in which we're working. So we work basically on applied research. We are not going into the fundamentals. We start basically, our objective is to build sort of prototypes up to TRL 4, TRL 5, TRL 6 that are later on taken by Venture One to get them to TRL 9 to the productization.
That sounds really cool. I mean, for me, I'm an emerging tech at Cisco, so it's a similar thing where we're doing things like this, and that's always the excitement for me is looking at new types of technologies, kind of iterating on it and figuring out how do we make this work best? What does it do? How can we make things better that are already created, and kind of just working on it? And that's the most exciting part to me.
Absolutely. Yeah, that's actually what we are doing, and it looks like it's a formula that works. Right.
So tell us a little bit about your LLM, because you guys do have a fully open source LLM, and first of all, why did you create it? What's the name of it for my audience, and why did you create it? Yeah. And tell us a little about it.
Yeah, so the LLM that we have created is named Falcon. The name is coming basically from the bird. Falcon is a national bird of the UAE. That is a symbol of courage and perseverance, right? So these are the values. Yeah, these are the values of the country, and it translates actually the whole spirit, I would say, behind TAI and behind the AI program that we are handling, where we are actually trying to exist among giants that are coming mainly from the West. So there is a courage to sort of handle this kind of or take this path, and we are making sure that we are perseverant in the sense that we are moving forward anyways, right? So dealing with the different challenges and the different constraints that are there. So Falcon has been actually released. The first model has been released back in May 2023, I believe. Yeah, it's the last year, and it was the 40 billion parameter model. It was trained on 1 trillion token. At the time, it was actually interesting because it was the time where the LLM started to pop up from different contributors. The nice thing is that the Falcon 40B topped actually most of the leaderboards and was on the top for several weeks. Then came other sort of LLMs that became first, of course, and then 4 months later, we came up with a new model that was the 1 180 billion parameter model that was trained on 3.5 trillion token at the time. But again, for few weeks, it was at the top of the leaderboards. So this is how things started, and now we are moving to more sort of sophisticated models in that line of models.
Yeah, I mean it's an amazing time. I mean it's very exciting because you have constant iteration on all of these different models. Everybody's coming out with different models,
Absolutely.
and and it's competitive, but it's also supportive because everybody's iterating off of everybody else's work. Everybody's trying to figure out what works, trying to figure out how to stop things like hallucinations and other aspects, trying to make it more fair and less biased. And I think that it's an exciting time, because you're going to see this constant iteration right now.
Absolutely, but I think it's a healthy, let's call it competition, right? It's a very
Yeah, yeah.
healthy competition. I would say it's a collaboration at the end of the day, especially from the open source perspective. All the actors who are participating in the open source AI community, it's at the end of the day, it's a collaboration. Everybody is trying to do better than the models that we had before, but then whatever people are doing, that gives new ideas for the other guys to do even better, to do more iterations. And from our perspective, we see it really healthy. We are not in a position where we are competing. We are in a position where we prefer collaborating with people to make sure that we integrate the best things. I think this shows also the multiplicity of iterations and the speed at which the iterations are going shows also the infancy of this field, right? So every day we are discovering new things, we are understanding things better, which helps us actually to do these fast iterations in the field, which results either in new models or new fine-tuned models or whatever new techniques that we can use to increase the safety, decrease the bias, and this kind of stuff.
Yeah, I mean, so how do you go about that? I mean, how do you think about, or what do you look for in these new techniques? I mean, there's new techniques in obviously training. There's new techniques in pipelines and all these other kinds of elements. What are you looking to optimize at this point, or figure out?
Yeah, so the first thing that we are looking at is really to look into the data. We believe that the data is the key for improving these models. Understanding the data, understanding how to get the highest quality data is a key to build new models. Eventually, that will be safer, that will be sort of embedding less bias. The second thing that we are looking at is how to decrease the conception of compute. So the during the training and during the inference, right? So when it comes to the training, we're exploring different techniques to make sure that instead of using, I don't know, 4,000 GPUs for 4 months, it will be nice to use just half for just 2 months, right? So if we build those models, I think there is a tendency also to go towards smaller models. Instead, there was initially a tendency where everybody wanted to build the biggest model, right? And nobody was looking at the impact, including us. I mean, I'm not blaming anyone. So it was an exciting time where everybody was thinking that bigger the model, better the quality will be, right? But I think we ended up looking at the problem in a different way, where everybody's claiming today that it's better to build smaller models that can go to the production at the end of the day, and this helps actually to optimize the model. So when it comes to the training part, we are indeed looking into that, reducing the size, making sure that smaller models actually learn more things, which increases the quality and then the efficiency. When we go to the inference, we are exploring different techniques like the quantization to make sure that the footprint of the models, we reduce the footprint at the end of the day, and we increase the efficiency using these models in a hardware that is not, I would say, high end, is one of the objectives that we have. We want to make sure that the models are accessible, and that's a key at the end of the day when it comes to the using less energy to run these models.
Yeah, it's interesting because I think there's going to be a convergence where, yes, everybody's going to go for smaller models, but also companies like Nvidia and all these other companies are starting to build this stuff into the hardware now. So even laptops and things like that are getting more and more powerful. So you're going to kind of meet this middle ground where you'll create smaller models, but you'll have better hardware at some point.
Yeah, absolutely. That is right. But I think there is also a need to think on the carbon footprint, right? So
Absolutely.
so we started again with these models where we were building actually monsters. Actually, if we can build a parallel between what what's happening in AI currently with the old time when we started building computers, right? So we have been building huge computers just to do some additions or multiplications, right? And
Yep.
then you have a full system that needs to run in the background to just do 1 plus 1, right? So,
Yep.
but with the time, things started to become smaller, but getting more sort of more outcome, more interesting outcomes. And today we have sort of mobile phones that are able to do a lot of operations that we want to do. I think, yeah, we have spent time building big models with, I would say, limited impact, limited safety, limit like a huge bias that is embedded. As we move forward, probably we are going to get into smaller model but more efficient model that would run on smaller devices, because the devices indeed are equipped with a better sort of hardware in terms of memory, in terms of processing, so on and so forth.
Yeah, I also often think about, where this is going because like the cloud providers, when at one time we were doing all this compute in servers and in racks and things like that, and it was all on prem. But then we decided that, hey, you know what? These cloud providers came out and they have everything we need in one location. We'll let them be the main point and we'll process everything there and then let them do it. I almost think the same thing will probably happen with AI, where you'll have a few of these mega hyperscaler type AI endpoints where they'll you'll connect into them and they'll have plugins to everything else you need, because nobody's going to want a different AI for each spot product. Nobody's going to want one for, say, I have to go to this prompt for security or this prompt for, they're
Yeah,
going to want to go to one place, manage it all there, connect there, and then let it do its thing. That's what I think. That's my theory on that.
yeah, that makes sense totally. The only issue I see there, maybe just to again feed the discussion,
Yeah, yeah,
is
absolutely.
I think the AI is much more complicated than the cloud paradigm, I would say, right? So we have a lot of aspects related to AI. The issue of the sovereignty, for example, right?
Sure.
So you will have a lot of governments who will just want their AI to be under them and controlled, understanding everything that's happening inside. This is one thing, right?
Yeah.
So you will have companies who will never actually accept to send their data to some sort of, let's call it a cloud AI that is there
Yeah, yeah.
doing everything for them. Although the result is nice, but well, I don't want to share my data, right? It's
Yep, yep.
extremely complicated at the end of the day. And I think there is a lot of bias that will always be there. The bias at the end of the day is coming from the data that we are using to train the model, right? And you
Yeah.
will have
Yeah.
some cultural, I would say, sort of exposure that will not allow your model that is extremely good to work in a specific culture, because they are not aligned with those kind of stuff. So
Yeah.
I think it will be a hybrid sort of future where you can have those models for, I don't know, for my public data, that will be perfect. But for some other operations, some other data, I may need to go to more sort of specialized model. They are sitting just next to me because I know what's inside. I can feed them. I can do many things to understand these models. So I'm not sure like how things will be. It's difficult to predict, but yeah,
It's definitely
you have
difficult to
different,
predict.
yeah, definitely. You have
Yeah.
different constraints that the future will tell us. But also on the positive side, every day, every week, we are getting better understanding of how these models work, what make these models biased, what makes them not safe. I think there is bright future that is coming ahead of us.
And maybe the internet's not the best way to train these models because the internet's all over the
that's
place.
Oh, that's definitely one important point. I would say, like we rely a lot on the data that is on the internet because we at least we believe that the data is public, so we shouldn't
Yeah.
have issues with the copyright, right?
Yeah,
But
yeah.
when you look into the data, in our experience, for example, we we went from a huge data set, and at the end of the day, we kept around between 10 to 15% of that data, right?
Wow.
So it just tells you, like, it's not because the data is there it is necessarily useful to train your model, right? People nowadays are moving to sort of generating data that is more artificial data, I would say, to train the model. But that's also dangerous, right? So how do you make sure that the outcome is really matching with the reality that you have, right? So I think, yeah, I agree with you, like getting the data directly from the internet, first is not totally meaningful, but
Yeah,
then it adds a lot of bias, right?
it
Depending
does.
on,
Yeah.
yeah, depending on who is talking more on the internet, probably you will get that model also trained on the same bias that you get on the data.
Yeah, so I mean, we're seeing a lot more now with things like RAG, retrieval augmented generation, things like that.
Yeah.
So it seems like that seems to be kind of the future, or at least near future, of where things are going with a lot of these things.
Yeah, I think the RAG is an interesting, indeed, aspect, but the RAG will not be working alone. The
Yeah,
RAG,
yeah,
from at least from my perspective, is just a component of the
sure.
ecosystem of the LLMs, right?
Yeah, yeah,
It's one thing that helps the LLM to be much more updated, for example, getting access to updated information. But then down the road, once we get into again, the productization of these RAGs, and having much more use cases, I'm expecting also some issues to raise from there, and then the need to look for eventually other solutions to help us solving much more complicated problems.
yeah. I think that there's definitely a need for more specialized instances of LLMs. And I think that's where kind of RAG comes in, where you have that specialized need, and then you
Yeah,
have to figure out, well, I need more relevant information, that I'm not
yeah.
getting from everything else. So um,
Yeah, that's correct. I think we understood that we reached the limit with the fine tuning. We cannot
yeah,
solve all the problems with just fine tuning the model at the end of the day, and that came after that to actually bring a solution to the limitations of the fine tuning. But now, where everybody is exploring the RAG and trying to, and it brings solutions actually to
sure.
many of the issues of the fine tuning, but we need to push it a little bit to the limit, as we did with the fine tuning, to see what's the limit and what needs to come afterwards.
Yeah, 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 totally. Um, so what about in terms of, one of the things that I often think about is how people can safely consume LLMs. We talked about on the beginning of this, you had mentioned how people were just, everybody in the industry is pretty much just creating LLMs with limited safety. And now corporations are kind of on the other end of that now, where they're consuming it without really understanding it because it's the cool thing to do. And it does, in certain scenarios, it absolutely does provide value. But whose responsibility is it to kind of implement safety mechanisms in these LLMs? Is that part of the LLM itself? Should there be outside? And this is obviously opinion. This is, should there be outside entities controlling this? What's your opinion on
Yeah,
protecting?
I think we have different stakeholders in this ecosystem, right? So we have the LLM, we have the RAG, for example, we have the people who will be fine tuning the LLM, we have the applications that are built on top of that LLM. So I think, in my opinion, it will be too easy to say that the people who are training the LLM are the ones responsible on that, because those people, they may not know, especially when it comes to open source LLMs, right? They may not have knowledge on where the models will be used down the road. So I think they have indeed part of the responsibility in the sense that they need to prepare the ground to have some initial checks when it comes to the safety, and they need to provide an architecture that is much more flexible and adapted to add additional controls on top of that. In my opinion, it's more a sort of a combined effort between all the stakeholders, right? The ones who are building the LLMs, the ones who are fine tuning, the people working on the rack, the people building applications on top of that. It cannot just be a responsibility of one actor in this ecosystem. This is the way I look at it, at least. And it's different levels, basically, where each actor has a contribution, has a role to make sure that these LLMs are safe.
Yeah, I mean, again, going back to the computing world and especially in cloud computing, everybody was in a hurry to containerize and go cloud first and cloud native and all these kinds of things. And so what happened is that, you had these newer people in DevOps that were kind of creating these things and saying, I just need to get the application up there. And
Yeah,
then afterwards, once they have it in test and dev, they're like, oh, we got to get to prod. No, 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 you have to think about how to secure this thing first, and you might not know how to do
definitely.
that. And really, we're in the same kind of, it's analogous to that kind of thing because we're in the same thing. We have these new things called LLMs, and we're trying to use them, and but you might have exfiltration and all these other kinds of
Absolutely.
things that you're worried about now.
Absolutely. And I think, again, the way I see also the relationship between these different communities is that you have people who have been going through these issues, although it's not the same, I would say, system, but it's very similar issues. Like you take the people in the open source systems, you take people from the cloud, you take people from different communities. They already went through these issues, and probably they found solutions for that. So the way the open source AI community is working today is that we feel like we are the ones who understood this problem, right? Like we don't see what others have done. I think there is a need to bring all this community together to look into this problem because everybody can bring sort of part of the solution, and then we can go much faster into making these models much safer, less bias, more efficient, so on and so forth. So there are lessons to learn from those communities, definitely.
Yeah, so that brings me to a point. When we think about the open source community, is what's the adoption been like? What's the how has it been as an open source project?
Yeah, I think with the interest at least is high. So if we look at the numbers, the different models have been downloaded around 40 million. Like we have 40 million downloads. We
Wow.
have different people working on different projects on that, building like applications on top, integrating them in their enterprise systems, so on and so forth. This helps us actually to get feedback that helps us to get new models. Well, we have different models that are coming. They are in the pipelines and will be coming to actually try to solve the limitations of the previous models that we have. So I think the community is there. This is one thing. We are supporting also the individuals and institutions to work on the Falcon LLM. So we are supporting them mainly with the compute when they need to do some fine tuning, to do some new projects that are built on that. And on the other hand, we have built or we have started a foundation that is Falcon Foundation, where we are trying to promote sort of some efforts or coordinate some efforts around getting Falcon much more interesting. So it's the same idea as the Linux operating system. So we give to the community the Falcon model, and we invite them to contribute on different aspects of the model. And we support them with compute mainly.
So how does it, do you work with any of the other open source solutions like Olama and all these other kind of things that are out there? Do you guys collaborate together or
We
yeah.
we would be happy to collaborate indeed, but I think we are in a context where everyone is too busy with with
Sure.
his problems.
Yeah, yeah.
But yeah, I think we learn a lot from what they do, and I'm sure they look into what we do also. But yeah, this is how the community is growing and working together. Yeah.
So in terms of developers, how would a developer consume, your solution? What's involved with that? Is it Python libraries? Is it, is there an SDK? What is it? How do they
Well,
interact?
yeah, well, we actually provide the model itself. All the weights of the
Okay.
model are provided as open source. They just need to download it and then package it in their Python or of the other languages, and then consume it. So the model is provided as is, different versions depending on the platform that you want to run it on. But yeah, we provide mainly the model, and people they take it further to either fine tune it or consume it directly.
And what kind of power do you need, depending on, obviously, a model depending on the
Yeah.
model you consume is going to be different, but what's recommended?
Well, the models that we have currently, the 40 and the 180, they consume some like compute power. If you take the 40B, for example, it needs two A100 GPUs, right? If you take the 180, it needs eight GPUs, A100. But the models that are coming will be consuming much less than this. Okay, we have worked a lot into uh, the compute footprint and the consumption, and they consume much less than this. But again, we had an era where these were not issues actually when it comes to the compute. The idea was, yeah, a company has to serve the model for consumption. We are not anymore in that view. We need to get those models to work on much less resources.
So, a couple more questions. One is, what have
Sure.
you seen that people have done that's maybe surprised you using these models? Have you seen anything that's been really surprising that people have created with these models?
Yeah, we have different examples actually, and we have the project that is around the combined with the telecom, like the Falcon and telecom.
Sure.
We have where basically the idea is to see to sort of discuss with a configuration of a telecom operator, right? The physical layer, and understand how things work together. What are the recommendations we can get to be able to sort of set up the network and these kind of things. You have security related projects when you basically try to find threats into sort of a network stream. And we have seen a project that is around the biotech. It's not done yet. It's not finished. Basically, it's on the way. But the idea is actually to understand or to have the LLM, the Falcon, understand the, let's call it, the genomics, and try to answer some questions and provide some analysis on this kind of data.
It must be it must be a proud moment, when you see people using something that you've created to kind of, do these kinds of things around there.
Absolutely, yeah, and I think that's the objective at the end of the day, right? Especially that we are fans of open source. The idea at the end of the day is to have people to use that, and the nice thing again is that you can receive feedback that helps you to improve yourself, right? That's definitely the case. I agree.
So we only have a few minutes left, but what are some things that we should leave people with? What do you want people to know about this project and about, maybe TII and what you're doing?
Yeah, so the first thing I would say is that we are proud of having this model and being part of the AI/LLM community. I think TII has provided good resources and good outcomes, shared them with the community. The journey doesn't end here, of course. There are a lot of models that are versions, I would say, of the model that are coming down the road, more efficient, more interesting, integrating multimodality, for example, safer, less bias on this perspective. And as I said, also we are pretty big fans of the open source AI. We are supporting fully the community to build on top of Falcon. It's not just by I would say speeches and discourses, but it's more We are concrete. We are providing more sort of support with compute. That is actually the blocking point for most of the members of the community to work on these large language models. So we are there to support. We are there to give a push. We believe that AI has to be open, has to be transparent, and has to be controlled by the community. And the community has to have a look into these structures and these models that we are building nowadays.
I love that, and I believe the same thing. So I think that's great. I'm definitely going to check it out. Post this recording, and I wish you all the luck, though. I mean, this has been great. This has been amazing to talk about this and to hear more about this great project.
Thank you very much. It's a very nice discussion.
All right, thank you.
Yeah.